Greetings, here's 7.2. We're talking about similar polygons. Okay, so as you can see, similar polygons are, as the definition talks about here, you got two polygons that appear to be similar in size, okay? And they're telling us in this example that they are similar. So a couple things they're asking us is list all pairs of congruent angles. So all we got to do here is zoom in just a little bit. So we're going to say R would be congruent with T, P with S, and then Q with U. And I kind of like to do it like that first. Then you could write your answer out and say, okay, for A, it's angle R is, whoops, I don't want to put a comma there, sorry, congruent with angle T, angle P is congruent with angle S, and then angle Q is congruent with angle U. Now part B asks us to write the ratios of the corresponding sides. So to figure out what the ratio is, we want to look at sides that are going to be similar, set up a fraction, and then reduce that fraction like we talked about in the last lesson. Okay, so for example, this side, the 20, would be similar to that side over there. So we're going to say, and you just got to make a choice. Do you want to go big over little or little over big? Doesn't matter, but just so that you do that for all of the sides. So for this one, let's go big over little, okay? So it would be 20 over 16, which reduces to 5 over 4. Then we got to check the other side. So we're going to take 15 over 12, because these are, again, corresponding sides. And again, that's going to be 5 over 4. And then we're going to check the last side, 10 over 8. And you reduce that fraction, and you're going to get 5 over 4. If all three come out to be the same, like this, then we know that those are similar polygons. If the we call that a scale factor. If you have little toys or something like that, you'll hear, what scale is this? It's a 1/64th scale or something like that, 1/16th scale. That's what they're talking about here is, you know, like this is the actual size toy, vehicle or tractor or piece of equipment, and then this would be like your little toy right here. Okay, so if all three of these are the same, then we know that they're similar polygons. Now, letter C, kind of squeeze this in down here. It asks us to check the ratios of corresponding sides. So we kind of already did that. I guess we kind of got B and C maybe in reverse. I guess that's kind of my mix-up. What they really wanted in B was for us to label the corresponding sides. So we'll kind of reverse these. Sorry about that, but I got the cart ahead of the horse. So basically, this side here is going to be similar with this side here. So let's label that as, whoops, not with a highlighter though. How about a pen? There we go. T, whoops, I'm going to start little to big again. Or I'm going to go big to little again. So I'm going to say RQ is similar. Now that one little squiggly line right there, I'm going to say is similar. And they really don't do that in the book, but they should. It is similar to TU. Then your next side, let's say RP and TS. So RP is similar to TS. They're not congruent. They're not equal lengths. It tells us that in the numbers. And then PQ, whoops, highlighter, Craig. PQ and SU So PQ is similar with SU. That's how you write the sides, just without doing any numbers. Okay, so I kind of mixed up B and C there a little bit. But for the most part, pretty simple. Just make sure, again, if you're going to go like I did, big to little, you're consistent with it. All right, don't go mixing them up. All right. Let's look at example 2. Now, we want to figure out, are these actually similar in this picture? A tells us to check corresponding angles if they're congruent. So let's just take a look. Okay, H and K are corresponding and they're equal. G, M, again, they're corresponding and those seem to be equal because of the double mark. Triple and triple. So A checks out okay. All right. I guess there's really nothing on the mark here, just maybe a check mark. And then B, see if the sides are proportional. Now we're going to do exactly like we did up in, should have been C, but I did it in B up here. We're going to check the ratio of these sides. So again, here now let's just go little to big. Sometimes if it even helps you, I write L over B, just to remind myself to go little over big here. So, and if it helps to highlight your sides or something like that, that's fine. So I'm going to say, okay, these two sides are corresponding, so we're going to say 9 over 12, which reduces to what? Put that in your calculator, and you should get 3/4. Again, you just put the fraction in and hit enter. Okay. Then this side, G, J, and ML, those are similar in corresponding parts. So we're going to say 15 over 20, which again reduces to 3/4. So far, so good. And then HJ and KL, so that's going to be 12 over 16, which again reduces to 3/4. So there we have it. Since all three of these came out the same, then we could say yes, they are similar triangles. All right, children, back to live action. Example 3 on page 2. Okay, we're going to figure out what X is here. He is somewhere in this area about right there. We just want to figure out the length of him. So what we want to do is we want to set up a proportion. If you recall from the last section, proportion is when you have two fractions like this, like, whoops, not the highlighter dummy, pen. Like 1 over 2 is equal to X over 4. Okay, and then we cross multiplied and solved, right? So let's label the similar sides, and let's set up an equation. So let's start with the X. So we're going to go little over big, so he would go with this side here. So if I'm going to say, okay, we're going to be X over 9 is equal to, and I don't know, let's just use this side here. You could have used the other one, it doesn't matter, but you definitely needed to use these two sides that I highlighted in blue. Okay, so we're going to say 10 over 15. I went little to big both times. Now we cross multiply. I always like to start with the variable. So I'm going to have 15x is equal to 9 times 10, which is 90. Divide by 15. And x is going to equal 6. So that is the length of this side down here, RT. He is 6. And that's all you got to do. Just make sure you're careful. Go little to big or big to little. You could have went 9 over x, but you'd had to make sure you went 15 over 10. All right? Either way, you'd get the same answer. Okay? Let's do another one similar to that, if we could. Okay, guys, so to give you another example of figuring out what the value of x would be over here, again, we want to take similar sides. So PR, whoops, I need a highlighter, dummy. Come on. Here we go. PR would be similar to SU, right? So I like to always start with a variable. And I like to have it on top here. So I'm going to say, okay, so that's going to be x over 9. This is going to be equal to what? Now, we've got to identify another side. You got 2 more to pick from. Just pick. Let's say 14 over 7. Okay? So that's going to be 14 over 7. Notice how x is on top here, 14 is on top here. This triangle, both numbers are on the bottom. I stayed consistent. Now we cross multiply. Always deal with the variable first, so I'm going to have 7 times x, which is 7x. 9 times 14. So that's going to be 131, unless I did that incredibly wrong in my head. Divided by 7.
126.
Oh, hold on. Getting intel from somewhere else. They're saying that's 126. Of course, it won't let me erase now, so I've crossed that out. Put 126. That's what you get for doing math first thing in the morning, right, guys? So now 126 divided by 7. Genius over there.
What was it?
126 divided by 7. I'm getting a phone a friend here. 18. So x is going to equal 18. All right, so this side up here, this PR, is equal to 18. All right, so hopefully doing this extra problem kind of helped you out a little bit with example 3. Zoom back in, talk about example 4. In example 4, we are really just wanting to, we got a ratio, we got 2 different shapes here. This is a swimming pool here in the middle, and then this is like the area, the patio around the pool. We need to find the ratio of the length of the pool, okay? So if we just want to find the ratio of the lengths, well, obviously, here's the length for the pool, but then here's the length for the patio. So if we're going to put a ratio, we could just say 32 over 48, and then reduce it in your calculator, and you get 2/3. So that is the ratio of the lengths of this patio to pool area. You want to have them, you want to have a good ratio so that way it looks right all the way around the pool. Okay, now we also want to find what is the ratio of the perimeters. So the distance around the pool and then the distance around the patio. Now all we got to do is add up sides. Obviously, this side on the patio is 48, and on the patio over here is 24. This is 32 in the pool, and this is 16 in the pool. So here's what we do is we're going to call this one, this problem A and this problem B. So let's add them up. 48 and 48, it's going to give me 96. Plus 2 24s is going to give me 48. Add those together, and you should get 144. And I'm just going to do this as one big fraction here, watch. 32 and 32 is going to give me 64. Plus 16 and 16 is 32. That's going to give me a total of 96. Now, here we've got our fraction for our ratio. Now let's just go ahead and simplify it. So in your calculator, all you got to do is take 144 ABC over 96, and you get 1 1/2, which a lot of times the math geniuses are going to say, don't put it as a mixed number, leave it as an improper fraction, so hit the second button and the ABC to your answer, and it'll give you 3/2. That's your ratio for the perimeters of the patio to the pool. All right, we'll probably practice those a little bit more in class. So hopefully you got the general idea of the similar polygons here. Okay, have a good day.